Hello student, today we are going to start the next topic of complex numbers chapter. So modulus and argument of complex number. Okay, so if z is equal to x plus iy is the given complex number, then modulus of complex number z is denoted by this symbol and it is equal to under root of x square plus y square. Now what this modulus of z geometrically represents? So all of you know that this is the complex plane, and if here is the x, here is the real part of z, imaginary part of z, then this point represents z is equal to xy. Z is equal to xy. Then the modulus of z represents the distance of this complex number from origin. So this part is called mod z. It is also denoted by small r. So the distance from the origin of complex number is called the modulus of z, and it is denoted by this the enclosed complex number in two vertical line. It is equal to under root of x square plus y square. For example, if z is equal to 2 plus 3i is the given complex number, then what is the modulus of z? Modulus of z is equal to under root of, what is the real part of z? It is 2 square, and what is the imaginary part of z? It is equal to 3 square. So it is 4 plus 9, it is equal to under root of 13. So what is the distance of this complex number from origin? It is equal to under root of 13. So hope you understand what is the modulus of complex number. There are some properties of modulus, that is, already you know find the z into z bar is equal to x square plus y square, and it is equal to mod of z square. जर तुम्ही previous video जर तुम्ही पुन्हा पाहिला तर आपण z into z bar means what, the complex number and complex conjugate त्यांचा प्रोडक्ट जर फाइंड केला तर आपल्याला असा आन्सर मिळणार आहे x square plus y square, but it is equal to what, mod of z square. So z into z bar is what, mod of z square. Now number 2, mod of z1 into z2 is equal to mod of z1 into mod of z2, and number 3, mod of z1 divided by mod of z2, that is equal to mod of z1 divided by mod of z2. So you can try these two for homework. So these are some properties of modulus. Now next definition is what, argument of complex number. Now argument of complex number. So argument of complex number. So all of you know that if z is equal to x plus iota y is the given complex number, then mod of z is equal to under root of x square plus y square. It represents the distance from origin, that is, if this is the x, here is the y, then here is the point z is equal to xy, and if we connect it from the origin, it creates an positive angle with respect to x axis, and this angle is called a theta, or argument of complex number z. So what is the argument of complex number z? It is denoted by arg of z. The detail about this theta we are going to see in polar representation of complex number, but you just in this lecture you just remember that what is the argument of z? It is equal to theta, and we can find this theta by using the symbol tan inverse y by x. Tan inverse y by x. But again remember one thing, this theta is not unique. That is, it is multiple of 2 pi. That is theta. If this theta is the argument, then theta plus 2 pi. Theta plus 2 pi is also argument of given complex number. Plus theta plus 4 pi is also argument of given complex number. But to make it into unique, we can So we can write principal argument. Now what is the principal argument? If your theta belongs to minus pi to pi, that is if your theta is lies between minus pi less than theta less than or equal to pi, then it is called a principal argument. So hope you understand why do we need a complex principal argument. Here our argument is not unique. Okay, if theta is the argument, then theta plus 2 pi is also argument, theta plus 4 pi, theta plus 6 pi is also argument of complex number. Now how to find this principal argument? There are again 4 cases. Okay, because our this complex number, there are total 4 planes. So we can find argument of z by using the exact location of our complex number. So if case number first, case number first if your x is 0, x is greater than 0, y is greater than 0, means what? Your complex number lies in our first plane, okay, positive plane. And this is plane. Okay, here is the x, z is equal to xy. Then this is what? Theta. Then you can find this theta by using the formula tan inverse of y by x. Tan inverse y by x. Now next, number 2, case number 2, if your x is less than 0 and y is greater than 0, means what? If your complex number lie in this coordinate, okay, minus xy, okay, this plane, second plane, okay, now second quadrant. Here y is positive but x is negative. Then this is the theta, because tan theta is always use the acute angle. So this is the theta, but since we always count angle from positive x axis to determine this theta, that is this is what tan inverse y by x. This is what tan inverse y by x. But this is the theta. This is the theta. But all of we know that this total angle is pi. This total angle is what? Pi. So pi minus tan inverse y by x gives us theta. So in second case, what is our argument of z? Argument of z is equal to pi minus tan inverse of mod of y by x. Now what is mod? That is you want to convert this x and y into positive. Okay, this is the second case. Now in the third case, if your x is negative, y is negative, x is less than 0, y is less than 0, means what? Your complex number lie in third quadrant. Okay, here since you want to determine, again this angle is given by tan inverse y by x. Now since we want the principal argument, we can't count आपण या डायरेक्शन ने angle count नाही करू शकत आहे, आपल्याला या डायरेक्शन ने angle count करावा लागणार आहे. We know that this total angle is minus pi. So minus pi मधून आपण जर minus pi मध्ये जर आपण हा angle add केला, then we get this angle theta. Okay, so what is the angle theta here? In that case, argument of z, I'm writing here, argument of z is equal to minus pi plus theta, minus pi plus tan inverse mod of y by x, tan inverse mod of y by x. And last case number 4, if your x is greater than 0 but your y is less than 0, means what? If your theta, if your complex number lie in fourth quadrant, that is minus x, plus x minus y, then in that case this angle gives a tan inverse y by x, okay, and which is also our argument of z. But since our direction is from in opposite direction, so we can write this as minus tan inverse y by x. So here, what is our argument of z? That is argument of z or theta is equal to minus tan inverse y by x. So all these cases I am writing here. So you just memorize these cases while determining the argument of given complex number. So it's very simple. Just I am writing here 4 cases. Number first, if your x greater than 0, y greater than 0, then theta is equal to tan inverse y by x. Very simple. Tan inverse y by x. Now number 2, if your x is less than 0, y is greater than 0, then theta is equal to pi minus tan inverse y by x, mod of y by x. What is mod? That is convert x and y into positive. So now next, number 3, if your x is less than 0, y is less than 0, then your theta is equal to minus pi plus tan inverse mod of y by x. And number 4, if your x is greater than 0 and y is less than 0, means what in fourth quadrant we can write theta is equal to minus tan inverse of mod of y by x. Now for an example, suppose you want to determine z is equal to 1 plus I. What is the argument of this complex number 1 plus I? If you observe here, your x is equal to 1, that is real part is 1, imaginary part is 1, that is both are positive. So in that case, theta is equal to tan inverse y by x, that is 1, and which is equal to pi by 4. So you must remember this, how to find the tan inverse. Okay, so for that you must memorize this table. If this is the theta, then this is the sin theta, cos theta, and by using this you can find a tan theta. So what is the standard angle here? 0 degree, then pi by 6, then pi by 4, pi by 3, and pi by 2. Pi by 2. 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Then here it is 0. Then here 1 by 2, 1 by under root 2. Then here under root 3 by 2 and 1. And if you write the reverse of this number, you will get the cos theta, that is 1. Then under root 3 by 2, then 1 by root 2, 1 by 2 and 0. So what is tan theta? All we know that tan theta is what? Sin theta divided by cos theta. So 0 divided by 1, 1. Under root 1 by 2 divided by under root 3 by 2. So this 2 will get cancelled here. It is 1 by under root 3. This 1 by root 2 by 1 by root 2, it is 1. And under root 3 by 2 divided by 1 by 2, 2 will get cancelled here under root 3. And 1 divided by 0 is what? Infinity. So since tan pi by 4 is 1, so tan inverse 1 is equal to pi by 4. So what is tan inverse of 1? It is what? Pi by 4. So hope you understand. Now next, suppose, so I am writing here x is positive, x is equal to 1, y is equal to 1. So here theta is equal to tan inverse 1, which is equal to pi by 4. Now in second case, suppose z is equal to minus 1 plus I. So if you observe, this complex number lie in second quadrant. So here x is equal to minus 1, x is equal to minus 1, and y is equal to 1. So since it lies in second quadrant, what is theta? Theta is equal to pi minus tan inverse of mod of y by x. So what is mod of y by x? That is 1 divided by minus 1. So what is 1 divided by minus 1? It is minus 1. But because of this mod sign, it is equal to tan inverse of 1. But what is tan inverse of 1? आत्ताच मी तुम्हाला टेबल दाखवला होता. Tan inverse of 1 is what? Pi by 4. So if you simplify this, it is equal to 4 pi minus pi. It is what? 3 pi by 4. So if z is equal to minus 1 plus I, then what is your theta? Theta is equal to 3 pi by 4. Now in third example, suppose your z is equal to minus 1 minus I. So here x is equal to minus 1 and y is equal to minus 1. Here x is also less than 0, y is also less than 0. So again third case, x less than 0, y less than 0. Then what is theta? Minus 5 plus tan inverse y by x. So theta is equal to minus 5 plus tan inverse of mod of y by x. So what is mod? Mod is what? Mod means what? आपल्याला पॉझिटिव्ह मध्ये कन्वर्ट करायचे. So it is equal to 1. Minus 1 divided by minus 1, it is what? 1. So what is tan inverse of 1? It is minus pi plus pi by 4. So if you simplify this, it is equal to minus 3 pi by 4. So this is the angle of complex number z is equal to -1 plus I, and last case, suppose number 5, z is equal to 1 minus I. Z is equal to 1 minus I. So here x is equal to 1 and y is equal to -1. So again this is the case, x is positive, y is less than 0. So what is theta? Theta is equal to minus tan inverse of y by x modulus. Mod hexapla. Mod is what? Always absolute value. It is always positive. So its absolute value kind of -1 divided by 1. It is -1. But what is tan inverse of mod of -1 is tan inverse of 1. And what is tan inverse of 1? It is -5/4. So hope you understand how to find the argument of complex number. Again, there are some properties of argument of complex number, that is, you can try for homework. Argument of z1 z2 is equal to argument of z1 plus into argument of z2 and argument of z1 divided by z2 is equal to argument of z1 minus argument of z2. Okay, so do you remember these two properties? What is the for modulus? Mod of z1 z2 is equal to mod of z1 mod of z2 for modulus, and mod of z1 divided by mod of z2 is equal to mod of z1 divided by mod of z2. So for argument of z1 z2 is equal to argument of z1 plus argument of z2, and argument of z1 by z2 is equal to argument of z1 minus argument of z2. So now write down an example. Find modulus and argument of complex number plus under root of z is equal to 3 plus 3 under root 3 I. Find the modulus and argument of this complex number. So here, what is the modulus of z? What is the real part of z? Real part of z is 3 and imaginary part of z is equal to 3 under root of 3. So what is the modulus of z? Modulus of z is equal to under root of x square plus y square. So it is equal to under root of 3 square is equal to 9, and the square of this term is equal to 27. That is, what is the square of 3? It is 9, and what is square of under root 3? It is 3. So 9 times 3 is what? 27. So 27 plus 9 is equal to under root of 36, and it is equal to 6. Since modulus represent distance is always positive, so instead of writing minus sign we will always write it is what? Plus 6. So this is what? Modulus of z. Now if you observe here, our x is positive, y is positive. So what is the argument here? Theta is equal to tan inverse y by x. Tan inverse y by x. So it is equal to tan inverse, since this a complex number lying in first quadrant, so it is what? It is tan inverse y by x. It is 3 under root of 3 divided by 3. So this is equal to this 3 will get cancelled. It is equal to tan inverse under root of 3, and I think tan inverse under root of 3 is equal to pi by 3. Pi by 3. Yes. There are one more example. Find modulus and argument of complex number. Modulus and argument of complex number. One plus I raised to 3. Find the modulus and argument of this complex number. So first of all, this complex number is not given in standard form. So what is our standard form? That is what is our standard form? We must identify what will be the real part and imaginary part of given complex number. Then it is a standard form. This complex number is not given in standard form, but we can write this as 1 plus 3 times I, that is a plus b cube. What is a plus b cube? It is equal to a cube plus 3 times a square b plus 3 times ab square plus b cube. So here a is what? 1, b is I. So a cube, that is 1, thrice a square, that is 1 square is 1, b is what? I. And then next 3 times a is what? 1, b square, iota square plus b cube, that is I cube. So if you simplify this, it is equal to 1 plus 3I minus 3. What is iota cube? Iota cube is what? I square into I. So I square is minus 1, so it is minus I. So if you simplify this, it is minus 2 plus 2I. Minus 2 plus 2I. So all of you know that. So this z is equal to 1 plus I cube is what? Z is equal to minus 2 plus 2I. So what is the modulus of z? Modulus of z is equal to, here real part of this z, that is real part of z is equal to minus 2, which is our x, and imaginary part of z is equal to 2, not 2r. Only imaginary part is what? 2. It is represented by y. So what is the modulus of z? It is under root of x square plus y square. So it is equal to under root of x square. So x square is what? Minus 2 square plus 2 square. So it is equal to under root of 4 plus 4. It is under root of 8. It also written as 2 times under root of 2. So what is mod of z? It is 2 times under root of 2, because this 8 can be written as 4 times 2, but 4 is what? 2 times under root of 2. Now what is argument of z? Argument of z. Now since this complex number minus 2, x is negative, y is positive, means what? Our complex number lying second quadrant. Now in second quadrant, what is our argument? Pi minus tan inverse of mod of y by x. Tan inverse mod of y by x. So if you simplify this, it is equal to pi minus tan inverse of y is what? 2 divided by minus of 2. So it is equal to pi minus tan inverse of 1. Because of this absolute mod symbol, it is equal to 1. So what is tan inverse of 1? It is pi minus pi by 4, and it is equal to 4 pi minus pi, 3 pi by 4. So what is the argument of z? It is equal to 3 pi by 4.